Let's talk about the breakdown point real quick. Breakdown point is when you have pulsed the cell a certain time span and the cell has achieved the highest voltage it can. That's when dielectric breakdown happens, current flow begins, etc., etc. So once you find that amount, you gate it. That's why this is the second level here, and that's why it's on this list. You gate the pulse. So it's basically two PWMs in succession to create a gated frequency, like I was explaining kind of in that previous video about the rotary VIC. So yeah, you gate it so it has a chance to reset to negative, and then you pulse it again. That reduces that amp flow and it keeps resonance, I believe, in effect. Exciter, electrical isolation, that is simply just insulating the tubes, making sure that outer tube has some kind of insulation on it. Mine is just a clear plastic tubing, not necessarily what he says to do, but that I think performs the same function. Inline resistor, that's a actual resistor from the negative inner plate to the ground. Perhaps if there's already enough resistance in the system, like I'm using series and stainless steel connectors, so that may function as resistance in the circuit, but basically it's just having the right resistance. But there's also a exciter plate, which is, I believe, where is that? This thing, which is a current inhibitor. Basically, stainless steel plate sandwiched between a non-conductive material of some sort. But all of these points add up to the fact that you can generate hydrogen gas at high pulse frequency, gated, as long as the cells are insulated and there's enough resistance to prevent the electron flow. And that's where we get this curve of potential voltage and production. Per my last videos, this is exactly what I'm talking about. Voltage wave burst, where we have a increasing positive and increasing negative respectively on each terminal, just like he says. That's what the VIC is creating. The rotary.
This is Stan's Revenge.